Okay, good question, Clarissa. So, let's see. So let's start with I. If you remember right, we were given. Here, I'll just. Mind you some of the things that we were given. So, let's see. I hope you guys are all having a nice night. I just got back from school, so. Um, let's see. My night hasn't been too bad. Oops. Let's see. Hopefully you can still see that. Oh, here, I'll just put it up here. Since we're concentrating on letters I, J, and K. So specifically, you were at, I was asked about I, J, K, and I imagine it's because it's cosecant, secant, and cotangent. And as you can see, based on the stuff that was given to you in the book, they did not give you those particular functions. But what you should know, and I mean, is that cosecant of x is the same thing as 1 over sine of x, which is also the same thing as sine of x to the negative 1 power. So once you get it into that kind of a form, sine x raised to the negative 1 power, now it becomes something that you could easily differentiate based on the information that you've been given. So cosecant just happens to be the derivative of cosecant would be the derivative of sine x raised to the negative 1, and we use the chain rule, so it would be negative 1 times sine x raised to the negative 2 times the derivative of what's inside of the parentheses, which is derivative of sine x is just cosine x. Okay, and so here we are, we have negative 1 times sine x to the negative 2 times cosine x. And if you check in the back of the book, that's not what they have for the answer. Even though what they have in the back of the book and this are the same thing, I'm going to show you how they ended up or how the back of the book got what they have. So if I simplify this, remember sine x raised to the negative 2 would mean we'd have cosine x divided by sine x to the second power, and of course it's negative. So we have negative cosine x over sine x squared. Still doesn't quite look like what they have in the back of the book. So I'm going to remind you of something. Sine x over cosine x is equal to tangent of x. Also, for the same thing, cosine x over sine x is equal to cotangent of x. Okay, and as you can see, if we end up factoring this out, we end up with equals negative cosine x. Oh, cosine c. I don't know what's wrong with me. Rhymes. So cosine x over sine x times 1 over sine x, because sine x times sine x is sine x squared. So cosine over sine x becomes cotangent of x. So this equals negative cotangent x times, and remember 1 over sine x, up here what we had, 1 over sine x is equal to cosecant of x. And that is what they have in the back of the book. Okay, so that's how you get the answer that is in the back of the book. But if you'd gotten to this step right here and worked it out and ended up with this right here, that would also be correct technically, even though this is the more simplified term. okay, or the more simplified version. So I will, here I'm going to pause it while I erase this so I can do J, K, and L. Let's see. Okay, so now we're going to do J. Secant of 2x, going to be similar to what we did with cosecant. So we have secant of 2x, and that's going to be the same thing as 1 over cosine of 2x, okay, which is the same thing as cosine of 2x raised to the negative 1 power. And just like before, we do the chain rule to begin with. So this ends up equaling negative 1 times cosine of 2x, raised to the negative 2, and that's times the derivative of what's inside. So now the rest of this, I'm going to change colors to keep this a bit clear. Well, this is still here. So what I'm going to write in red now is going to be the derivative of cosine of 2x, which I also just happen to use the chain rule for as well, which is going to be the derivative of cosine would be negative sine x. So negative sine of what's inside the parentheses, which is 2x, and that's times the derivative of what's inside of the parentheses. So the derivative of 2x is just 2. So here in purple, gotta love these colors, we have the kind of quasi-finished answer so far, which is negative cosine of 2x raised to the negative 2 times the negative 2 sine 2x. So all I did is just, bring that 2 up into the front here. Now you also notice we have a negative times a negative, which becomes a positive. And if I end up rearranging this so that, that this negative 2 here actually takes effect and becomes a denominator, we end up with 2 sine 2x divided by what's in here, which is cosine of 2x raised to the second power. So cosine 2x squared. Okay. Now you'll notice this is similar to what we had before. Remember, we had sine over cosine was tangent, so we end up with 2 times tangent, 2 times tangent 2x times, and we're still left with a cosine of 2x down here, times, remember 1 over cosine of 2x is going to be, you guessed it, secant, secant of 2x. Okay, and so that is your final answer for J. Okay, now I'm gonna leave K for you guys, and we'll see. If you still need help with K tomorrow, I'll still go over K, and I'm gonna skip on over to L, because you got that cotangent cubed. So here we go. We have L is, well, here, let me erase this really quick. Erased. Okay. So L, the derivative of 8 cotangent to the third power x, x over 2. So there's a couple of things we need